So we all are back to main room. How was your experience?
Nice one.
Okay, so
That bracket was in out of place. That's why I got the
okay, yeah,
doubt.
I said like I also do these mistakes quite a lot of time, but if you do it once now, then you will remember it.
Yes,
So
ma'am.
there is a value to mistakes also because you remember your mistakes.
Yes, ma'am.
Okay, that's good, Divya. So we will start with the multinomial logistic regression. And since you have done this binomial, so you will find this relatively easy. Means like assumptions, you don't have to test for assumptions in multinomial regression. And yes, but interpretation is a little because you will see that there are two levels probably. We'll discuss those things. So this multinomial logistic regression in binomial, what we have seen that there are, if the dependent variable has got two levels, but what to do if our dependent variable has got more than two levels? So in that case, we will see how to, there are various ways to tackle this. So many people, they suggest that you can club these variable like two of these variables and make it as a binomial. As for example, in this case, you can see that there are variables and there are various categories or level. For example, if you see this choice of contraception, if you see this choice of contraception, there are three probably categories. There is a OCP, there is a copper T, and there is a MDPA. Similarly, pain, if like I have this levels of pain that is the mild, moderate, and severe. If I talk about this preferred method of follow-up, then I may define it in three categories: telephonic follow-up, in-person follow-up, and by mail. If I'm determined, if my this dependent variable is a vaccination status, so I may have three categories like non-vaccinated, partially vaccinated, and fully vaccinated. Similarly, if my dependent variable is of tumor grade, I may have a grade 1, 2, 3, 4. And if my dependent variable is a preferred teaching method, I may have a categories or levels which are having like preferred teaching method by PowerPoint, by chalk and talk, and in the interactive board. So in this case, there are two sort of variable. There is a nominal variable and there is a ordinal variable. All these variables has got more than two levels. So can you tell like in which of these variables there is a natural order? Means which is the ordinal variable. So Dr.
Tumor
Neeti,
grade.
yeah, tumor grade, vaccination
And
status,
pain
and
also.
pain, very
Pain.
right, very right. So yes, you are right. All these three, tumor grade, vaccination status, and pain. In all these three cases, there are levels which has got more than two, but it's ordinal in nature. So if a variable has got more than two categories, we call it as a polytomous variable. Like if a variable has got two levels, like we have just seen, it is known as the binomial. If it has got more than two levels, then it is known as the polytomous variable. So we have to look for the orders in the categories. So if our dependent variable, like you have seen the tumor state grade or the pain status or the vaccination status, if these variables has got a definite order, then what type of logistic regression we might choose? That's a ordinal logistic regression. And if there is no order, then we have to choose a multinomial. As for example, in the previous one, if you choose, if you want to see the odds of a female preferring OCP, copper T or MDPA, then you will not go for ordinal. You will go for multinomial. Why? Because there is no order in this case. It's all are discrete. It's a multinomial. Rather, you can say that there is no order. It's a nominal. So multinomial terms comes from the nominal. So, that we have not discussed, but I guess all these types of measurement scale where you have got a nominal, there is an ordinal, there's an interval, and there is a ratio. So, in this case, this is this copper T or this telephonic follow-up or this, preferred way of teaching. All these three, if you see these three types of dependent variable, they don't have an order. I can't keep OCP as 1, copper T as 2, and MDP as 3. Even if I give other numbers or I change these order, the intuitive meaning or the interpretation is not going to make any difference. But I cannot do the same thing with pain, vaccination status, and tumor grade because there is an order. So if a variable has got more than two levels, first is it's important to identify whether that level is in a natural order, which is ordinal, or it is a nominal scale. That's why it is known as the multinomial. So if there is a no order, then you will go for a multinomial. And if there is an order, you will go for an ordinal logistic regression. So yesterday also we discussed when I was showing you the gem movie that in logistic regression, there are three options. We'll see it today it's also that there is a ordinal logistic, there's a multinomial, and there's a binary. So we have discussed binomial logistic regression yesterday and tomorrow also, and today we'll discuss multinomial. So how to do such analysis when outcome has got multi-level? So the simple approach is you can club the categories. Like you can club this copper T and MDPA as one category if I see, and you can take OCP as one category. Or you can club this telephonic and by mail as one category and in person as one category. So here there is a example of this ordinal also. You can club this mild as one category and you can club moderate and severe into one category. Similarly, you can club these tumor grade 1 and 2 into one and tumor grade 3 and 4 into the other. So we have, because we know how to run a multinomial, how to run a binary logistic. So what is the general tendency? I might club these category and I will run a binomial logistic regression. But this is not recommended. Yes, you are right, Arif and Hera, that it will cause a loss of data. Very right. And again, in case of ordinal, at least there is some meaning. But in case of multinomial, it will not carry any meaning. Like, what is the basis of combining the in-person and telephonic and email? Ultimately, it will not carry any meaning also. And Arifun Hera is very right that there will be a loss in the, what you can say, in the data. So here you can see this, by this figure, I am just showing that this is like in the form of ordinal, where I have given these as a 0, 1 and 2, and I have clubbed these 0 and 1 into one category, and then 2 as another category. Same, I am just writing here like I have clubbed these none and mild into one and moderate and severe into one. So I have clubbed these two as none or mild, and I have clubbed these two as moderate or severe. So, but again, like Arifunera was telling, that there is a disadvantage because there is a loss of detail. How there is a loss of detail? Because you have collected the variable, you have categorized the variable based on some definition or some percentage. And then if you again club these two together, that finer detail of those variables will not be available to you. So that's why, and even the interpretation, it will be very generic. It will not be very specific. So that's why combination of these categories are not recommended. And again, what I can do, I can run many binary. So how I can do that? So what I can like convert these multinomial variable into the many binomial variable. As for example, I can convert three separate binary logistic regression. I can run this in-person versus telephonic. Then I can do like email versus person and telephonic, and I can do like telephonic versus email and in person. So I can convert, if I convert all these, and if I run these separate binomial logistic regression as I'm just telling you why we should not do. One is the, like we have seen, one reason is the loss of detailing. The second is, like we will see in this example, that there will be increase in error. How this is possible? That if you club these category together and you have to run three separate logistic regression, because then you have to calculate the odds in A, calculate odds in B, and calculate odds in C. So you have to calculate three odds ratio. But you know that odds ratio for three models, you will have three probability. And we know that if we are defining that some event will, yes, Dr. Darkoi is very right, there will be alpha inflation. This is similar to very much similar to, running multiple independent sample t-tests when there are more than two independent group. Like we always say na, that if you have to compare the mean in more than two independent group, like then if you perform like many two or three independent sample t-tests and not run ANOVA, it will lead to increase in the error. Similar concept is here. If you run like three binomial logistic regression, at the total probability value, if you see, there will be one equation for probability of this outcome A, and we know that for this probability, what should be the value of probability if I am assigning this probability of A as outcome? What should be the value? At least it should be more than equal to 0.5. Again, in case of this C versus A plus B also, the equation will give some probability of outcome for C, which will again be either 0.5 or more than that. And for B also, if B is the outcome, then probability equation will give some probability for occurrence of outcome, which is again more than 0.5. So if you club these three probability together, it will be more than 1. Why? Because at least 0.5 should be there for that outcome to happen that we discussed yesterday, seeing the probability. So if you club all these three probability, it will be more than 1, which is not possible. But because we know that the upper value of probability value can range from 0 to 1 only, it will not go more than 1. So that's why for individual value, the probability should be a sum of, like, all these three should be equal to 1. It cannot be more than 1. So that's why separate binomial, if you run separate binomial regression, your total probability will be more than 1, and it will increase the standard error of estimation, which is the B. That's why you should not run a separate binomial logistic regression for a dependent variable when it has got more than two levels. And such problems can be resolved by using the multinomial logistic regression. So what happens in multinomial logistic regression? So basically in this example, like if you see, there are three levels: in person, telephonic, and email. So multinomial takes one of these levels as a reference value, and it makes two models. So it will take like email as a reference, and it will calculate the odds ratio of in person versus email and telephonic versus email. So it will make two model basically. And again, you can change the reference level also. If you wish to change the reference level, you can change the reference level like we have seen in the GEMOV. And for K levels, if you see, for K levels of these variables, the multinomial logistic regression, it makes K minus 1 model. That means if there are three levels, there will be two models in your multinomial logistic regression. If there are four levels, there will be three models. So number of models, why? Because one value it takes as a reference. So that's why it will make K minus 1 model. So let's see how this runs in GEMOV. Oh, yes, we have shared the article also with you people. I will just show you some important part of this article. So this was the assessing the prevalence and factors related to frailty in community dwelling older adults, a multinomial logistic analysis. So if you see the author, he has discussed what are the factors, what is frailty? Frailty is basically the weakness. So he has defined the frailty into, divided the frailty into three category. One is the robust, where person is not frail. The second is a pre-fail category, and the third is the frail. So I'll just show. So if you see the data collection and the assessment that they have written regarding how they have collected the data and how they have measured the various other variables, like they have measured the polypharmacy, the morbidity status, suffering from diabetes or not, and they have measured this PIM, which is the potentially inappropriate medication, whether they were taking or not, and they have done this frailty assessment using this tool, which is what this suggested by the Fried, and again they have seen like what are the other characteristics. Like they have measured the IADL, which is the instrumental activity of daily living, and also they have measured the leisure time activity, and they have measured the morbidity status. If you see the statistical analysis, so they have performed the exploratory data analysis. So exploratory data analysis is again descriptive, and the frequency table they have used to describe the study variable, and taking into the account the three possible state of frailty, they have divided the frailty into pre-frail, frail, pre-frail, and robust. And they have performed this multinomial logistic regression was used to study the relationship between the independent variable and the outcome variable. And all independent variable, like they have included all the independent variable in the regression model. Like they have not performed some adjusted, crude and adjusted one. They have taken all the independent variable as a predictor variable. So this they have given just the descriptive statistics, frequency table, and mean for the continuous variable, and frequency is for the categorical. And if you see, like they have given this table. So if you see this table, so they have written that like factors related to frailty, and the reference category in this case is the robust. So that's why this is the odds ratio of being frail as compared to robust, and this is the odds ratio of pre-frail taking the robust into the category. And these are all the like you can see age, then comorbidity index, Lawton, Brody, IADL, gender. They have taken two variable which is continuous in nature, which is the age rather than three. Age, morbidity index, and the IADL. These three they have taken as a continuous variable, and the rest of the variables are categorical, like gender, diabetes, heart disease, respiratory, bone and joint. Psychopathology, how they have measured? Psychopathology, they have measured whether the person is suffering from depression or anxiety. And if the answer to either of these is yes, then there is a psychopathology. Polypharmacy, they have taken yes if the person is taking more than five or more than five drugs, and then this is the PIM. So this they have measured, and they have shown this odds ratio of this frail and pre-frail. So we have just the data which we are using. We have tried to the data set which you have received. That's dummy data, means we have created that data just to show the findings of this paper, and I will show the questions too. So this is the what we are supposed to do. So again, we have written something as a background that the frailty is a common geriatric syndrome characterized by a decline in physiological reserve. Yes, Dr. Arun raised his hand.
Yes,
Dr.
ma'am.
Yeah,
Yes, ma'am.
पूछिए
Ma'am,
आप.
yes, ma'am. Ma'am, when this table was shown and the continuous variables, that is the age and the fidelity index was shown, ma'am, ये continuous variable में like how do we like interpret this thing, ma'am? Like age तो continuous variable है, ma'am. तो fidelity compared to robustness was 1.19. तो मतलब इससे क्या इन्फ्लुएंस निकल रहा है मैम मतलब कि मतलब थोड़ा I was wondering.
मतलब इसमें यही है कि अगर एक साल जैसे हम उसमें करते थे बाइनरी में कि 1 ईयर अगर एज बढ़ रहा है तो फ्रेल में फॉल करने का उस बंदे का जो odds है वो 19% times हाई है. If you wish to say it in percentage, if you wish to say in, because you see, like in case of multinomial there are two levels, means again there's a categorical and there is a continuous, but again the dependent variable, because it gives you, again we discussed that it gives you two model. So here the frail which you are seeing, the first column, if I am discussing this first one, this one, right? So 1.19, if I express it in percentages, it says that there are 19% high chance of falling, high chance of odds of falling into the frail as compared to the robust. Similarly, the same, this 9% you can write, you can see here. And others also, like if you see this IADL, so it is 0.53. So you can see, you can say that there are six, if you increase this this by 1 unit, because in case of a independent variable, if it is continuous, we always say that there is an increase in 1 unit of this predictor variable will have this, there is a 60 not 47%, there's a 47% lower chance of falling into the odds of falling into the frail category as compared to the this robust category. And if you read their interpretation, I'll just show. Because if we were also see, you can see what they have written. Have you gone through the article? Have you read the interpretation part?
No, ma'am.
Okay, so if you see, if I read this, in order to further examine the impact of independent variable, let's first see this thing. See, age was also related to frailty. For each additional, this is like creating problem. Let me delete this comment. Okay, so if I see the age was related to frailty. For each additional year of life, odds of being frail increased by 19%. Can you see this? For each additional year of life, the odds of being frail increased
Yes.
by 19%. They have expressed it in the form of percentage, not in the form of odds. And again, like I guess you know this, because yesterday we did not discuss, if there is each additional year, means if there is an increase in 2 year, then what will be this percentage?
38.
So no, it is not 38 actually. I think we discussed this in few of our previous workshop. It's the multiplication actually, because it will be 1.19 into 1.19. Right. So 2 year will not make it. So how that 19% is calculated? Okay, 19% is like it's 1 point. How do we do it in case of odds ratio? It's like we from 100 or from 1. So from 100 you just make it in percentage. So it will be 119. So that's why it comes as 19%. Odds is more. So in this case, like it will be like odds ratio minus 1. Are you getting it? So 1.19 minus 1. So that's how it's 19%. Dr. Tanya. It's not
Yes,
11.
ma'am. I got it.
11,
I got it.
11.9, I don't know. 11. You have written 11.9. I didn't get.
Now I understand, ma'am, that we have to
Okay.
deduct it from one.
Yeah.
Then we convert it in percentage.
Yeah, that's how we interpret odds ratio if we are expressing it in percentage. But for 2 year, remember, it will be like, if I have to ask, you will not do like it will be like 1.19 Let me do it on the calculator. How much will be there? Because many people there is a confusion that they just multiply this.
61. 19 multiply 19.
No, 1.19 multiplied by 1.19. So how you will do
1.19 multiplied by 1.19.
Yes, we do like that.
If 1 year it increases 19%, then
नहीं 41% हो गया नहीं 1.41 वो कैसे एक्सप्लेन होगा
Just a sec. What is the value? 41%. Yes, that's how the interpretation of odds ratio is. That's how. So there will be, because the more you multiply, this will not go very high. If you multiply 1.19, since the value is higher, maybe if it is less than 1, it will go further lower. So that's how we discuss this, increase in age. So Dr. Arun, is it clear to you how to interpret like 1 year increase or even every additional increase the odds of being frail, like it's written, and we know also.
yes मैम मैम वो कंटिन्यूस वेरिएबल का डाउट हो रहा था, वो समझ आ गया मैम। जैसे आपने समझाया कि मतलब कि अगर 1 यूनिट इंक्रीज होगी तो फिdelity के odds कितने बढ़ जाएंगे।
हाँ, 19% जैसे अगर परसेंटेज के टर्म्स में हम बात कर रहे हैं तो।
जी मैम, जी मैम, थैंक यू मैम।
So we have seen this, and now we will see the question. So I was just explaining this. No, there was one more hands raised also. I think 2, 3 hands.
Shweta.
Shweta.
Ma'am, actually, I got the answer.
Okay, good. Chalo, theek hai. So this was the what all we are supposed to do here. This is just the write-up. You can see this. What all variables I have to use. So I have to use age, gender, and then dependent variable is my frailty status, which I have categorized as robust, pre-frail, and frail. There are 3 categories. The age here is the continuous. Then again, this IADL, the instrumental activity of daily living, that is also continuous. This gender is categorical. Okay, here we have taken IADL as 0 to 8. So maybe you can, it is continuous for us because we know that any ordinal scale where the levels are more than 5, we treat it as a continuous. So it is continuous for us. And then heart disease as a binary, yes and no. Diabetes, again, yes and no. Respiratory disease, yes and no. Bones and joint, and polypharmacy. So these are this thing. So I will just show you the data set. We have shared the data set with you people. So if you see the variable data, just check with the reference level, which is the 0 and 1. So female is 0, male is 1. If you see this age is continuous. IADL is again continuous. Heart disease is a nominal, no and yes. This is again 0 and 1. Respiratory disease 0 and 1. Bone, all these are 0 and 1. And then this is our dependent variable. So I've kept, you can see it is the robust, pre-frail, and frail. Again, you can see this that there is, although they have performed a multinomial, but you can perform this thing also. What you'll say, ordinal, because there is a definite order in this case. Because robust, it is not, all the categories are not unrelated to each other. Based on that index, which the author, I think that Fry's index. So there will be some score. And that score have categorized these. Robustness will have a higher score, pre-frail as middle, and frail as probably the lowest one. So although he has performed a multinomial, but if you see the dependent variable, can you appreciate that the categories are not unrelated to each other? Do you agree or not? I don't know. Can I see the chat box?
Yes ma'am, they are incremental ma'am.
Yes. So we will, once we see the ordinal logistic regression tomorrow, then we can see, like in many cases, it happens that if the assumption, because in multinomial, you will see that there are no assumptions. We don't have to test for the assumptions in case of multinomial. But for ordinal, we have to test for very important assumption, that is the assumption of proportional odds. So what happens, ideally what they should have done, that they should have tried the proportional odds assumption first. And if that assumption did not meet or there was some issue with that assumption, then they should have performed the multinomial. Are you getting what I am trying to convey? Ideally, if there is a ordinal nature of the dependent variable, one should try for this ordinal logistic regression, right? But in this case, you can see here that I mean, they had directly gone for multinomial. So many people, they treat the ordinal also as a discrete category, and maybe you can also do like that. But if you see the reference books, they always suggest that if the ordinal nature of the variable is there, then you should first see the assumption of proportional odds, and then if that is not met, you can opt for this multinomial logistic regression. So anyways, right now we are demonstrating this multinomial logistic. So these are the robust, pre-frail and frail. And then you can see what is the interface. So how I will go, I'll go to this analysis, click on regression, and like yesterday we discussed, we have to focus on these three options, which is the binomial, multinomial and ordinal. So right now I will use this option of multinomial. So if you click this multinomial, then this interface will appear. Again, everything is same as you have seen in the binomial or binary logistic. Interface, even the coefficients, the interpretation, except for interpretation, which we will discuss how it is different. So first, how I will go for this multinomial. Again, what all, because they have written that they took all the variables in the model. But again, if you're predicting or if you're saying something, then we should go the way we have gone for the this binomial logistic. So first I will move this frailty to dependent variable, and one by one I'll see the this thing. So I'll first check with this gender, and I'll see what is the p-value or significance. So if you see this, it will give you two model. So can you just shift that chat to side? Yes. Thank you. So you can see that if I have moved this variable, there are two models. First, I'm just showing with one variable now. So there is this gender is there with it gives you the odds ratio. This is 1.31. And this is the odds of pre-frail. So how will you say that the odds of male is 1.3 times higher of falling into the pre-fail as compared to the female? Similarly, here you can see the odds ratio is 1.71. So how will you interpret the odds of male falling into this frail category is 1.7 times as compared to the female? So in isolated, you can see what is the value. So if you see the p-value, so p-value is up till 0.19. This is 0.19 and this is 0.06. But in adjusted, this unadjusted, this gender is not significant. But again, this is borderline significant. So I will take this gender as a model. Although the author has taken all, but I am just for a demonstration, the way we have done the binomial, we will do this also. So this I will take in my model because this is up till 0.2. Then I will move this back and I will enter this age here in the covariate. Now you have to see what is the value. So if you see again, it will give you two model. One model is like of pre-frail as compared to robust. It has taken robust as a category. And then frail versus robust means the reference category is the robust. So if you see the age, again, the p-value, it is significant in both these cases. If you see, this is also significant, this one, and this is also significant. So I'll also take age because age is also in unadjusted this thing or univariable, it is showing the significance. Then I may go for this IADL and I can see, so IADL also you will see that it is significant, both these values. Then I'll see the heart disease. And maybe all the way there's also all the variables for here also you will say this is significant. And this is diabetes. One more important reason that the sample size is very high. If you see their sample size, it is 500, I think 490 or something. So if the samples, let me check where is the sample size. If I can recall correctly, yes, 582 patients. So with 582, their sample size is very good. So if your sample size is very good, like much more than required, then you will see that most of the variable which you make model, the prediction of your model is good, and the variable also which you take, most of these will come significant. So you can see here that P, but again for diabetes, it is not. You can see diabetes is yes and no. It is not significant in this case. And this respiratory disease, if you take, this is again this is borderline significant because it is 1.169. If you see the p-value, it is 0.16 up till 0.2 and it is 0.255. This is again this is little more, but again you may take this. Again, you can see the bone joint disorder and you can check for the p-value, it is significant. Yes, Dr. Arun, बताएं आप.
मैम मैम ये जो सैंपल साइज मल्टीनोमियल लॉजिस्टिक रिग्रेशन में जब कैलकुलेट किया था हमने, तो जैसे हमने बायनोमियल में देखा था कि हमने इवेंट रेट्स को कंसिडर किया था और हमने ये बोला था कि एक इवेंट के पीछे 15 हमें चाहिए करीब करीब सब्जेक्ट्स। तो जैसे 15 × 690 हो गया था। इसमें मैम इसमें क्या मैम इसमें भी वही चीज लगेगी मैम क्या इवेंट
इसमें एक्चुअली
नॉन इवेंट?
मॉडल दो बन रहे हैं, तो डेफिनेटली इसमें बिकॉज देयर मॉडल आपके दो हैं, तो इसमें वो क्राइटेरिया नहीं लगता है। इनफैक्ट मल्टीनोमियल का सैंपल साइज मुझे लगता है हम लोगों ने चेक नहीं किया है कि कैसे करते हैं, क्योंकि जनरली सैंपल बट इतना है कि उससे ज्यादा चाहिए, क्योंकि इट इज गिविंग यू टू मॉडल्स इन दैट सेम सैंपल। सो आई गेस इट इज मोर देन दैट, एटलीस्ट मोर देन दैट, बट आई हैव
अब
नॉट।
यदि यदि
मैं
मैम कोई स्टडी ऐसे हो रखी है
हाँ
और
हाँ
और हमें हमारे पास कोई डेफिनेट मेथोडोलॉजी नहीं है सैंपल साइज कैलकुलेट करने की, तो क्या हम उनके ऑड्स रेशो को लेके अपनी स्टडी में इंक्लूड करके कैसे कैलकुलेट कर सकते हैं क्या हम?
हाँ हाँ बिल्कुल
तरीका है।
बिल्कुल कर सकते हैं, एकदम कर सकते हैं,
लॉजिस्टिक का पूरा सेशन सैंपल साइज
कर सकते हैं ये। और कभी कभी जनरली क्या होता है ना, कई बार ऑलरेडी डेटा होता है, मतलब ज्यादातर आप देखेंगे कि जैसे हमने कल वाला भी देखा था, वो इलेक्ट्रॉनिक वहां से मेडिकल रिकॉर्ड डिपार्टमेंट से या ये सब जो लार्ज डेटा सेट होता है, ये इनके पास ऑलरेडी डेटा होता है। तो उसमें क्या होता है कि बहुत सारे आर्टिकल्स में आप देखेंगे कि सैंपल साइज कैलकुलेशन का ऐसा कोई जस्टिफिकेशन दे डोंट उन देते नहीं है। वो कहते हैं कि इतने सैंपल थे और इसमें हमने
स्मॉलेस्ट
लगाया। सो दैट वी कैन डू, बट जैसे आप बता रहे हैं ऑड्स रेशो भी ले सकते हैं। उसमें जनरली क्या है कि वैसा वाला आउटकम लीजिएगा जिसका सबसे कम वैल्यू है, सो वैसा ऑड्स रेशो लीजिएगा जो कि कम है, तो उसके हिसाब से, क्योंकि उसका सैंपल फिर ज्यादा आएगा। वैसे तो ऑड्स रेशो का भी पता नहीं होगा आपको, एक लेवल पे ज्यादा आता है फिर धीरे धीरे उसका कम हो जाता है, तो 1.5 या 2 ऑड्स रेशो पे शायद सबसे ज्यादा सैंपल साइज आता है, तो वो
जी
लेके आप कैलकुलेट कर सकते हैं।
जी मैम, थैंक यू मैम।
वेलकम। So this is also significant. So I think only one variable which was diabetes was not significant. Rest of the variable it was significant. This is also, if you see that p-value, it is significant, 0.003 and 0.31. One is not significant, the other is there. But again, so you can see this is the 1 by 1. Now, if you see the other, this thing, model fit statistics is there. and model coefficient is there. But you will see that this doesn't give you the probability. So actually, what happens here in case of multinomial, that we have discussed that the total probability is 1 and it gets broken into the 3. Probably, I think I will show you on SPSS if time permits, because in SPSS it gives you all the 3 probability. But that we will show you after you are through with this movie. So this frailty, now I will go for this model making and I will include all those variables which are significant in the unadjusted or the when I was performing the univariable multinomial. So in this case, I will move this gender here to the factors, this age and ideal here, heart disease, diabetes I'm not taking, but for demonstration I'm just taking, otherwise it is not significant. And then since the author has taken all, that's why probably to simulate their table, we have taken everything. And if you come down, again, these are the model fit statistics, overall model test, which is important, the McFadden R-square. And in model coefficient, you can click, already it is clicked, odds ratio and confidence interval of odds ratio. And if you want, you can click this likelihood ratio tests. Otherwise, you can leave, because we have discussed that this likelihood test ratio test also gives you the important significance value of the predictor, which is calculated based on chi-square, whereas this predictor significance is calculated based on Wald statistics. So if you see this, now we'll see the interpretation. So interpretation is the deviance and AIC. I'm not, if you see the R square, it is 13%. So it says that there is an improvement of 13% over the null model. But overall, if you see the p-value, it is significant. So it is better than your null model. And you have included all these variables. So if you see the p-values, the gender, age, ideal, heart disease, and the bone joint, it is significant. Polypharmacy is like borderline. In fact, it is, you can take it as 0.06, so it is not significant. So diabetes was not significant initially also. Respiratory disease, diabetes, and polypharmacy. That is not a significant predictor. The significant predictor is gender, age, ideal, heart disease, and the bone joint disorder for this frailty. So this was the overall. Now I will show this to you one by one. Let me increase. If you want to increase this field, there's a 4 dots here. If you just, it is not happening. Okay, let me do it from here. Many times this movie. I'm clicking, but it is not happening.
ये मैपिंग पे है
No, it shows all this now.
इसको उसमें
See, there is an arrow here, and I am doing it.
वो ये
If you make this hole will come like this. Yeah, initially it was not getting now. Okay, so
यहाँ डाटा
if there is an arrow, if you press this, and then
अब डाटा पॉइंट रहता है तो
yes, if there is a data, then only this comes. So this data, then it will move. Okay, so to make this move, this field should be in data. Like if it was in analysis, it was not moving. So these are some finer details which sometimes it creates like a problem, but again, it will be resolved if you keep on trying. So like you can see here, I was trying to explain this table and I was not getting the enough field. So now you can see that there are 2 models. So here I am discussing this first model. Just a sec. I am discussing this model first. Okay. Then I'll come to the other model. So if you see this model, the gender, male versus female. So initially, if you can recall, there were, when I was doing the unadjusted, means the univariable, the male were having the higher odds of falling into the pre-frail status as compared to the female. But in adjusted, you will see that the males, the odds ratio has gone down. It is 0.43 in case of a male. So how can I write the interpretation? So I will, what I do, 100 minus 43. It comes like 57. So I will write that there are 57% less chance of falling a male into the pre-frail category odds as compared to the robust. Similarly, for age, since it is 1.05, what will I say? That there are 5%, since it is in plus. So 5% chance, every additional increase in 1 unit of age or 1 year of age, there are 5% more chance of falling into the odds of pre-frail as compared to the this robust. Similarly, if you see the IADL value is less. So I will say that there are 32%. So 32% less chance of falling into the pre-frail as compared to the robust. Similarly, for heart disease also, I can say like 1.88. So I may write that if the person is having the heart disease, the odds of falling into the pre-frail category is 1.88 times as compared to the person who is not having heart disease. Similarly, for respiratory disease also, you can say if that if the person is having respiratory disease, the odds of falling into the pre-frail category is 0.67, or it is 33% less as compared to the person who is having no respiratory disease. So similarly, you can explain these all values the way we have done for binary logistic. The only thing which you need to realize in this case is that there are two models, because it was having 3 levels. We have defined our dependent variable into 3 levels. What are those levels? There is robust, then there is a pre-frail, and there is a frail. So if you have defined your dependent variable into 3 levels, then it makes K minus 1 model. Why? Because it takes 1 as a reference point. So one reference, it has taken robust as a reference point. So that's why you will take that it is giving you 2 models. So this is one model, and then there is another model. So the second one is this one. And this also, I will explain the similar in the similar way. If you see here also, the male, it is showing the odds is 0.25 times. So odds of, if the person is a male, the odds of falling into the frail category of a male is 0.25 times, means 75% less. Means female were more likely. So if you want to like make, because if you see the author result, they have made like female as a in the male as a reference category, and they have shown it in the females. I'll show you the article if you see the result of this article. Yes, they have shown like in female, in gender, they've written in the write-up also. The main factor of being frail was a female gender. Thus, in the sample, the female frailty odds was 20-fold the male frailty odds. All other covariates being equal. If you see their frailty of being frail, so the female gender was having 20.54. And of being pre-frail, it is 2.53. So they have taken reference as a male. In our case, it is the reference is the female. Why? Because if you see the reference category, if you wish to change the reference category, if you want to see it in male, then how will you do it? You will make this male as a reference category. And then you can see what is the odd. So you can just wait for some time. and then you can see here. Again, I will go to this data and I will increase this view. So now if you see the odds ratio, this is 2.33. So you can write that odds of being pre-frail was 2.33 times more in female as compared to male. Similarly, if you see this male frail also, then odds is 3.97 as compared to the robust category. So you can change the reference level also. Okay. So can we, Dr. Arun is writing, can we try between frail and pre-frail? Means you want to make the reference category as what, Dr. Arun?
Ma'am, as pre-fail, ma'am.
Okay, yes, you can do that. You can do anything which you wish. So what you can do here, you want to make the frailty status, which what I should choose as? Frail as a reference.
Pre-fail, ma'am.
Okay, pre-frail. So if you click pre-frail, here all these references are okay, or do you want to like male and female? Then wait for some time and you can
जी मैम
see. तो आप देख सकते हैं फिर रोबस्ट अगर होना है तो फीमेल का चांस कम है, ये उल्टा होगा उससे. इफ यू सी दिस, द ऑड्स रेशियो इज 0.43. The odds ratio, I'm just discussing one variable. Why? Because there are many, then we will get confused. So just with gender, I'm discussing more just to make other variables, it'll make you having a feel that you have understood. So this
जी मैम
फीमेल का 0.43 है, इसका मतलब है फीमेल का फॉलिंग इनटू द रोबस्ट, odds of falling into the robust is 0.543 as compared to the male.
और यहाँ 57% कम प्रोबेबिलिटी है रोबस्ट होने में
हाँ,
मेल के
उसको
कंपेयर
परसेंटेज, अगर उसको परसेंटेज में करेंगे तो ऐसा ही है. अगर नीचे भी आप आएंगे, अगर आप रोबस्ट को देख, फ्रेल और प्री फ्रेल, आपने तो यही पूछा था ना कि
जी मैम
फ्रेल और प्री फ्रेल. एक मिनट, उसको मैं बढ़ा देती हूँ डेटा.
जी मैम मैंने यही पूछा था
हाँ, तो अगर आप देखेंगे इसका, तो इसका है 1.71. मतलब एक फीमेल का फ्रेल कैटेगरी में फॉल करने का ऑड्स 1.7 टाइम्स है एज कंपेयर टू मेल.
यानी 71% ज्यादा है फेल
फ्रेल
में
फ्रेल
आने का
फ्रेल. तो आपको हर जगह
जी
से
मैम
दिख रहा है कि फीमेल्स आर मोर ऑड्स ऑफ बीइंग इन फ्रेल. चाहे
जी
आप
मैम
यहाँ पे कोई भी, यहाँ पे प्री फेल आपने लिया है रेफरेंस, या रोबस्ट, रोबस्ट में कम है उनका, क्योंकि रोबस्ट का अगर
जी
आप
मैम
ऑड्स रेशियो देखेंगे तो वो 0.43 है.
जी मैम जी
तो रेफरेंस लेवल आप चेंज कर सकते हैं. अच्छा, दो क्वेश्चन लाइक देन डॉक्टर मोनिशा इज आस्क्ड व्हाट इज दैट इंटरसेप्ट. एक्चुअली इंटरसेप्ट हम लोगों ने कल डिस्कस किया. Intercept हम लोगों ने, we have discussed it yesterday, and that is the why. If you like make a regression equation, then the value of all the, if you make the all the predictor variable as 0, then the value of dependent variable is known as the
देखिए
intercept.
सारे
And I think Dr. Arun has also asked its intuitive meaning. So we discussed this, we have seen this, but we could not, like we say that whatever value, whatever data set you have, your model is effective for that data set only. So generally, if you see if there is a continuous variable in your predictor variable, then that value is never 0. So that in that case you can say that intercept has got no literal meaning. But yes, of course, if you have got a data set, like in case of a categorical, and the model which you have made, it is like using the data set of your own this thing. Like let's say if age is there, so you cannot make age 0. Why? Because you have not collected anyone who's having age 0, and practically 0 age is not possible. So that's why it is a hypothetical situation. That intercept, it's a mathematical thing. Every time it doesn't have an intuitive meaning. Dr. Tanya, so intercept, have you understood, Dr. Munisha? Dr. Tanya has also raised her hand.
Ma'am, in the reference level that you chose earlier on,
Yeah,
before this, there was an odds ratio for the female to be in the frail group. It was 2.33.
yeah.
How can we calculate the percentage for the female one in case when it is more than 2?
Again, 2.33 minus 1. So you will write 133%.
Okay, thank you, ma'am.
Welcome. Yes, Shweta. Shweta, yes, you have raised your hand.
Yeah, actually, when we are comparing robust and pre-fail, the odds ratio in the gender is 0.43. So won't we say that here it is protective? As we say, if it is less than 1, then it is protective.
Which like right now I have changed the reference category. You are taking pre-frail, frail or robust. Which one you are taking as a reference?
Actually, the value was 0.43, which I could see in the gender for odds
Okay,
ratio.
wait. Then that was Dr. Arun's question when he took the pre-frail as a reference. Okay. So I'll go to that.
Yeah,
So you are saying pre-frail, this one, like 0.43.
yeah.
So but see this now, this is robust. So yes, 0.43 means that the lady is not going into the robust category.
So, like we were saying now, it would be 43% or something of that
No,
sort.
100 minus 43. So you will write there are 57% less. Because
But when it was 1 point, something has happened with my screen. I'm not able
actually,
to.
see, you have to see the value. You can see the value of these intercepts estimate also. If the estimate is in negative, that means
Mhm.
the odds ratio will always be less than 1. If the estimate is
Okay.
in positive, that means the odds ratio will always be more than 1. So by this sign means like there is a reduction, means like the odds is getting reduced of being into this robust category.
Yeah,
Similar
but
way, you say
yeah,
that
yeah, yeah. So
you
if
are saying
we are
protective.
saying, yeah,
Yes.
I was saying the odds ratio is less than 1, it's 0.43, then we can say that females have lesser chances, 57% less chance of falling into the robust group.
Yes, means they will fall into the frail or pre-frail.
Okay.
And
That
that's
was
what,
what I was trying to ask because where it was 1.73, we were saying 73% more chances, and here we are saying 57%. So it would be lesser. Okay.
did you get it? Like it's all about the reference category.
Yeah, yeah. Okay.
Anybody else? Like who? I will again change it to robust because in the original, the article which we have shared, they have taken robust as a reference category. Okay. But again, it is up to you. If you wish to do any analysis, you are free to choose the reference level, wherever, whatever you want to show. So that is regarding the, and then I will show you how to write the interpretation. So since there are no assumptions in this case, so there's no need to write for the assumption. So this is the table which we have just tried to make the table. And here we have not written the unadjusted or the univariable odds. So because then table would have been very, horizontally spread. So we have also written like pre-frail versus robust. This is one category, like one model, pre-frail versus robust and frail versus robust. And these are the like, you can see the odds ratio. We have just given the odds ratio and the upper and lower, this thing, their border with all the variables. And then it is the interpretation. So if you see the interpretation, again, we have just written like the binomial logic. One of you can read this just, just to have a feel. How do we write? Yes, can someone read? If not, I will have to read. I may ask someone. Yeah.
Yes, ma'am. Ma'am,
Yes, there were two voices, Priyanka and one other person.
Ma'am, I was the one.
Okay, so you please do this favor for me. I will just highlight the section so that it is easy for you. Till
Okay,
this
ma'am.
you can read.
Ma'am, yes, ma'am. So, ma'am, the result states that the multinomial logistic regression analysis demonstrated a significant improvement in the model fit compared to a null model, with McFadden's pseudo R square indicating a 13% increase from null model. Gender, age, instrumental activities of daily living, heart disease, and bone and joint disorders were significant predictors of frailty status. Females were more likely than males to be classified as pre-frail, bracket odds ratio 1.28, 95% CI from 1.25 to 4.22, or frail with the odds ratio of 3.97 with a 95% CI of 1.77 to 8.91. Increasing age was associated with higher odds of being pre-frail, odds ratio 1.05, 95% CI 1.02 to 1.09, and frail with the odds ratio of 1.07 with a CI of 1.03 to 1.12. Functional status as measured by IADL was protective against both pre-frail with the odds ratio of 0.68 with a 95% CI of 0.57 to 0.81 and frail with the odds ratio of 0.47 with a 95% CI 0.37 to 0.60 states, ma'am. So, ma'am, participants with heart disease had higher odds of being classified as pre-frail, the odds ratio of 1.89, and frail with the odds ratio of 2.33. Similarly, bones and joint disorders were associated with increased odds of pre-frail with the odds ratio of 1.71 and frail with the odds ratio of 2.71. While respiratory diseases show a trend towards significance for frail status, it was not significantly associated with pre-frailty, with the odds ratio of 0.67. Polypharmacy was associated with frail status, with the odds ratio of 2.06, but not pre-frail status, the odds ratio of 1.14. These findings highlight the critical role of age, gender, functional status, and comorbidities like heart disease and bone and joint disorders in frailty progression.
So thank you,
मैम
Dr. Arun. Yeah, you were saying something. Sorry.
मैम ये जो आईएडीएल था मैम ये जैसे ही अगर बढ़ता है मैम ये स्केल तो ये प्रोडक्टिव दिखा रहा है मतलब कि आई मीन ये उल्टा नहीं होना चाहिए था मैम जस्ट क्यूरियस
IIT का better score is good.
प्रोडक्टिव मैम ओके मैम
बेटर स्कोर इज गुड. वो आपको देखना पड़ेगा कि जो ज्यादा स्कोर है वो जगह ज्यादा स्कोर होता है तो हम बताते हैं कि वो ज्यादा इंडिपेंडेंट है.
एक्टिविटी ऑफ डेली
जी मैम
एक्टिविटी ऑफ डेली लिविंग जितना ज्यादा स्कोर होता है इसका मतलब मैं सारी एक्टिविटीज अच्छे से कर पा रही हूँ. तो ऑफ कोर्स अगर मैं सारी एक्टिविटी करूंगी तो मेरा फ्रेलिटी तो कम होगा ना.
जी मैम जी
understood.
आइडियल का इसलिए कम है क्योंकि ये तो स्कोर मतलब ज्यादा अगर आइडियल स्कोर होगा तो प्री फ्रेल और फ्रेल कम होगा. आई थिंक
जी मैम क्योंकि ये कंटिन्यूअस था मैम तो अगर इसकी एक यूनिट बढ़ती है तो फिर वो दिखाता है कि ऑड्स रेशो और मतलब कितना कम.
जी जी जी. ऑड्स मतलब प्री फ्रेल में फॉल करने का ऑड्स इतना परसेंट कम होगा. मतलब अगर 68 है तो 32% कम होगा.
मैम क्योंकि ये कंटिन्यूअस वेरिएबल था तो और कैटेगोरिकल नहीं था तो इसकी इंटरप्रिटेशन ये होगी कि अगर जो मुझे समझ आ रहा है मैम कि अगर इसकी एक यूनिट बढ़ती तो ऑड्स रेशो इसका फीमेल्स में प्रीफिल में फॉल करने का
फीमेल्स में
0.68 होगा.
फीमेल्स में नहीं. अब हम अब आइडियल की बात कर रहे हैं तो फीमेल नहीं करेंगे. अभी आप आइडियल बता रहे हैं कि फीमेल क्योंकि
आइडियल सॉरी मैम सॉरी
ओके इट्स ओके. आई गॉट इट. मुझे बात समझ आ गया. आपने सही बोला. और एनीबडी एल्स हु इज हैविंग एनी अदर Like, do you want to ask something? Else we'll go to the breakout room. Okay. If not, Supriya, kindly open the breakout room.
Yes, ma'am. Opening the breakout.